All right. So let's see here. Okay, welcome everyone. So what we're going to do today is actually fix things, right? Fix things that are usability problems. So I was actually off, like I just watched Soding's video cursing C3 for its behavior, and that's also awesome to have that feedback. So the problem here is that right now, if you look at this, is that when you have like the command is accepting files, it will put all those files into uh, the main build, the main directory, the one that you are issuing the command from. And the reason I'm doing this is that it seems to be what Clang and all of those are doing, unless you actually set the build directory. But the downside of this, of course, I mean, the upside is that I'm not creating any directories. So, in case the compiler doesn't have the rights to actually create new directories or do anything, I like it, it's the problem. Then, yeah, it will not need to do that. So that's the advantage. But the disadvantage here is that obviously, um, Sodium complains about is like where just the files are kind of messing up everything when it just barfs them, right? And if you have a project, that's not a problem because it will have a build directory and everything will end up there. But kind of getting these defaults is like I'm just like thinking of every possible permutation of what people might want. And in that case, uh, this becomes something of like guesswork, and people will be upset regardless of what I pick. But it's also hard. It's I'm not using the language for this enough to have a solid opinion by my own, right? So let's, you know, I was thinking let's fix this, right? So we still have in the case here where we have the um, build directory. Look, we're getting like the object file is going to end up in temp here, like a build temp. That's where the object files are, and then there's going to be a like the lvmir folder in case we have any lvm output. And by the way, there was people reporting that this lvm output you got that even though you didn't do anything about um, you had this output for some reason shouldn't be there, but there was some output there. So anyway, so to go back to this, what kind of default can we pick? So the obvious thing would be like have a build directory that would be like a hidden directory, so you wouldn't see it, you wouldn't be annoyed by its presence. But in the case, I think like okay, so now like making guesses, right? It's a problem. Making guesses is a problem. But let's say like we're setting the build directory now. We can probably assume that if you're setting the build directory but you don't have um, okay, so first up we have the build directory. So in the case we should really pull this out. So if we don't have a build directory set, so options don't give us a build directory, and uh, in that case, let's pick build. The other case would be that we have a build directory. We want to target the build directory in the project. In that case, it's build. We don't have anything that's kind of barfing things into the main folder. Okay, so that's the first part. And then we go to the next part. So the next part is like if we have an IR file. So basically you're saying, let's output some LVM IR. Now, in the case of having, if you have set a build directory now, let's say you did indeed set a build directory. So, okay, first of all, the basic would be like to take these and set it to the LVM out if you have that one, right? In this case, if we haven't set that, we might have this default directory which is build. So if we don't have a target now for the IR, this is like guessing again. So feel free to have opinions on how to do this, right? So in the case where there isn't an IR directory, and that means we also then we can do two things. So if we have a build directory, then we probably want it inside of that build directory. And then we're going to do like it does, we do it here. That is, we're going to take the we're going to take sorry, if we have a build directory from the options, right? So from the options we have a build directory. In that case we use this option build directory and then add LVM IR. But if we don't have that, then in that case we want to just give it a name. So then, like in this case, we actually asked for it. You know, let's do output IR somewhere, right? So then maybe we want that IR like immediately. Okay. So that would be, it would be placed inside of that and not barfed into the current directory. Now what I could do here though is to say whenever I do this, let's prefix this or suffix this with a target type. And that might be useful. So in this case, we can instead do like this on the chart. So we have the build dir. We could also have like completely different build directories, right, for per target, and that would make Soding really happy, I think. So maybe we should do that. But let's for now, for this will just give us the build directory, right? So it's this. Oh, what did I do wrong? So the build here. Oh, no question mark. Missing that. So the EIR build directory. Okay, and then this one could be like could also be by target, right? So it could be like a file str format. There's a str format, right? Okay, I have to use Scratch. Use the Scratch buffer. Oh, that's bad. So what did I call that? Is there a str format, right? vprintf, okay, but did I have some str format? No. Okay, then maybe I should do that. So okay, then I'll use this Scratch buffer. So we're gonna have that and clear it first, and then we're gonna have append something with format Scratch printf. Okay, and then we gonna have what? We're gonna have like build, build, and then underscore, and then this target, right? So what's the target? And the target will be this arc OS target, but can I get that back to name, please? Arc OS target from string, yes, but the other way around. Arc OS target. Okay. Arc OS target, and then build, I guess. No, target, sorry. Target, arc OS target, something like that. I don't remember if this is correct, but then we can make a like in this case where we need it, we can then do a copy like that, which will make a string copy of that we gladly leak, by the way. Okay, so that's it. And then in the case where we have someone who have the IR, right? And then in that case, we have this file append path, which is important because it's actually adding this slashes to it. But in that case, maybe we also want this IR, this to be different. So if it's not an IR, so we don't have that, again, we can do clear this, right? We can clear it, and then we call it LVMIR underscore target, right? And then we can do the same thing here. We can do a scratch buffer. That can be a toString because it will probably, let me see here. Will it? Oh, it will return a name if the path is empty. So that's not good. But the path will not be empty, right? Maybe it will be. I wouldn't count on it. So we're going to do a copy. Otherwise, we're also going to do a copy, right? We can do the copy here, I guess. Sorry, I've been sick, so. So what's that called? There we go. I have a very small screen right now. Slightly annoying. We can make it a little bigger, but I know how to adjust. Let's see here if we can just make it a little bigger and then adjust it for you so you can kind of see the screen. Oh, maybe you see the screen anyway. That's fine. Okay, hello everyone, by the way. So now we have the IR, so we're doing C programming, right? Yes, and then we are finally we are assigning this whatever build directory we have, right? Okay, why did I do like that? I wouldn't want it to be in a different place. Let me think about what I was doing because now I'm confusing myself. So we have the IR, we append the target, and then we finally add the build directory if we have one. Otherwise, we are just going to put it in the LVMIR underscore thing that we created. We could also, make something like a subtargets, subfolders, which might be much nicer. Like currently, what I'm doing would be, you get build, right, and then build, and then inside of that, you will then get like LVMIR Mac OS x64, something like that, and then we get like LVM IR, and then it's a flatter thing. You would get Windows x64 and so on. So you get all of these, in there, and then you get, I guess, if you have ASM, and then you get the .o file might be in there as well. So this question is like, do I do it like this, or do I do it like, it could also be, and then you have like Mac OS x64. So, and then you have all the data in there. So it's, I guess, like if I do this, then it's cleaner to kind of have the IR, because then you don't have to look for that. If anyone has any other opinion, you can tell me. So what we're going to do now is basically we are going to get a build. So it's always going to be like the build here is going to be the same, but we're actually going to do one level down. So what I mean by that is that if we have build here, then we have that one, yes. But otherwise we do not this, but we do file append path, and we take build, and then we append the this target. So const char target name. We need that for other things. So let's pull it out of that over here. So okay, so like that, and again, this is only if if it does the default thing. So now in the case we don't have any build here. If we have a build directory, then we go for that, right? Very sorry about that. So otherwise we just go for build. Okay, but we don't do different things for the .o files. So then in the case where we have an IR file dir, we just use the LVM out. But maybe it should be a subdirectory in that. There, if it should be like it's still in a subdirectory to LVM. No, it's gonna be. It's an interesting question, because maybe if you set this, you expect, regardless of where you put it, it's not going to be put in a subdirectory. You just want it there. Let's go for that right now, and if not, then we'll deal with that later. So in this case, we have two options. One is that there is a build directory. In that case, we're going to file append path twice. So we're going to, get this, or actually we don't need to do that, but we want to have LVM IR, right? And then in that we want to have this target name. And if we don't have that, so let's see, we append it twice, right? Let's see. So we have an option, so we take the build here, and then we add this, and then we add the target name. We don't need to do that, we can just be LVM, I think. Okay. And otherwise, we are still going to append a path. We're going to take just LVM in the current directory, and then we're going to add the target name. So basically, things will end up in LVM Mac OS x64 or something like that. Okay. So that was the IR files, right? And that's, we're not done yet. So the next one would be the ASM files, and we need to deal with those in the same way. So we are going to take like the ASM files, if you have some of that. So you're going to place that by default in whatever you say, but if it's not defined, then you want to go for like ASM filed. If you don't have that, then you go for the build here. If it's not, then we have like ASM here, and then target name ASM there. Let's see what else we have. So we have the object files, right? And so we're kind of done with these files. So now finally we have the object files. Now the object files by default is going to end up in the build directory. So it's going to be in here, except if you actually say where you want the object files. So the target, so I'm going to put it here as well. So the target object file here is going to be options object out, right, where the object files will end up. But if we don't have that, then if there's a question if there's a build here or not. If there is one, then we put that in ob or just ob. So like that. And now we can kind of apply the same thing to the projects, I think, because the projects will do something similar. So it looks like the projects are doing the same thing. There is a script here that is not in other places. So the script directory is where you run the scripts. So in this case, I think that the script directory where you run the scripts is going to be like this. Basically, you need to set it. So if there's not a script directory, it's going to be like whatever this target is, target build directory, right? So here we kind of avoid, we set everything, but we kind of avoid we can kind of do this, right? So in the other case, in this case, we can set the build directory, right, from the options. But then we have the case, this other case where we are compiling it differently. So in that case, we do it again, it's going to be different because we're going to say, first of all, if there is no script directory, so okay, if there's no target directory, so we don't have any target build directory, then if the options, like if there is no target build directory, so target build directory doesn't exist. Let's see how this works. So this is overriding things, yeah. So we can't override the target one. Let's see. Can't you do this in target? I mean, can't you read that? Nope. Okay. So there might be a target build directory. So in that case, if there's a target build directory, then okay, so the options might be overriding that. So something like if not options build here, then we're going to set the target builder to the options builder to the target options builder equals. So if the target doesn't have a builder, target build here, it doesn't have one, then it's going to be build. Or if we don't have a build directory from the options, like this, so options build here. If options, sorry if it's hard to kind of follow, but yeah, what does that? If we have some build here in the options, then we can override that. If otherwise we don't have any options in that, then we can override options with target, which by now should have something. And then we have like the script directory where we have that or the target one. But if target script, no, if you don't have that, then target script directory is scripts or something script. Scripts. Okay, and then we can just remove this, I think. Because then we go these output files, depends on the options, right? And then if the target has this IR file directory, if it doesn't have that, then we set it through this. If it doesn't have an ASM one, then we set it through this. And this is just taken from the options anyway. So something like this. I have to look through the code again to make sure that I'm doing something right, or how badly I'm doing something wrong. So first of all, I hope that by this time here in the code, we'd actually have actually set this architecture. I can't say for sure that we have, so I'll just run this here, see where we go. So let's see if I can have a single compilation. So, oops, so we have something badly done. Okay, and that's somewhere else. Here it is. I think I accidentally included something. Okay. So now I come here, let's see what the this target name is. It's null. That's not what I was hoping for. What is the target arc OS target at this point in the target? So it's not been set, or oh yeah, no, there is none in the target yet, I guess, because it's going to pick that from the options. Let's see here where that's set. So we go there. By this time, it must have been set already, because everything else will be totally. So init default build target. Default build target, doesn't that have an architecture? So it doesn't have an architecture. That's not so good. So let's see, maybe I'll get interrupted here. Okay, hang on. I'll just mute a little while. And then, let's see. All right, so let's see, we go back to this. we didn't have the options there. They are not correct. So that's a bit annoying. Let's see here again. The options are, does it have the architecture? The override is not there, right? Yeah, but the target here should be set, I think. So this is a bit annoying. Init default build target, and that's going to be the target here, yes. But the target doesn't have any target set yet. Let's go a bit further into this. We're gonna go up here, here, here. Damn it. One more time. So we're gonna go in here. We're gonna go in up one step. We're gonna go into compile here, and now we're setting up some things. So don't we know what the target is yet? Compiler build. What does that one say? So the compiler. Now let's see what the target is. So somewhere here. Where is the target? Architecture. 43 more items. Okay, let's see. So maybe, yeah, it just says Arco is target default, which is very annoying because we want the target already. So when it says default, I can't do anything about it, so I can't actually insert those subfolders here if I want them to. So essentially this target name doesn't exist. At this point. But something here should already know about that architecture, I think. I know we don't do we do the detection fairly late. The decision what to compile for. But I think by here we already know it. So there is something here. Spans. It should be in here. Why doesn't it know? Why doesn't it know already what type it is? It's inconceivable. Oh, there's the target site up here, and so I think this can just go into the part that I was looking at. Right. So we can do this earlier, so we actually get that knowledge of those subfolders. So here, and there's no reason why we don't do it here. I think we have the default target. Yes. So okay. So here then, we are kind of, let's see what happens. So now we're here, we kind of get that target name, which should be then a real name, like Mac OS in this case, because I'm on a Mac. And then we're going to make the build directory, and then these are not going to be set. So we go in here, and then let's see what the options build here is going to end up looking like. So the options: build dir, um, somewhere 55 more items. There are a lot of settings. You end up with this insane amount. Okay, build dir is now LVM. That's not what I. Oh, great. So this is the IR file. IR file dir, right? This is actually the target. IR file dir. So I was thinking, like, well, didn't I do something that looks so like this, right? And it's going to be like the object file dir. And then if the build dir is there, we're going to add that. So let's see what happens now. So let's compile some things and just run with it and see if something breaks. So okay, so we have my test things here that we are not going to use anymore. So we're just going to want to run this program. And oh, now it failed to create the build directory, right? So, and why did it fail to do that? Well, it didn't know to create these directories in between, I think, because just assuming that there is like a single. Why is it asking for ASM? By the way, that seems wrong. Because you should only ask for this if you actually have ASM output. Oh, again, same thing. So now it looks good, I think. So, okay. I failed to create this output directory. That's good. That's good. So we're going to try to create the things in between too. So we have a dir make, right? But this is not dir make recursive, which we already have. Actually, why doesn't that take a... Oh, it needs a copy. So I can just make one then. So we can make a scratch buffer clear here, and then I just append that one. Append the directory, because that one is not supposed to be messed with, and then we just do toString here. Then it doesn't matter. So it's going to be okay. No, what? Okay, let's see what happens. So we, oh, wait, create output dir. Doesn't that fail to create output directory? That should be exactly there. Oh wait, that's another one. See, it does. This one doesn't have these. So there's another one. Let's see. Right. So there's the other one here. So make, and we have to make it recursive, right? So dir make, and then we can make. We want the recursive one, so then we need a scratch blah 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 clear, a scratch buffer append, and then do the compiler build. Have this thing. And then take this scratch buffer toString and that one over. Then we do the same thing here, and we do it a lot of times. Okay, let's just extract this. So let's say static void create dir if needed. Do we already have one of those? So in that case, we could do something like so if not dir, then return. If there is one and it exists, oh, we're gonna have this. So scratch buffer clear, scratch buffer. And dir, and then finally dir make recursive, scratch buffer. Okay, so if it exists, so we can do like this. So if this directory exists, then we really hope that that's a directory, not some file. If it does, then we do this. If dir make recursive, then we do the whole of this. And scratch buffer to string. And finally this. So because we will have to die if it fails. Okay, so let's go here. So if we have a build directory, now we will have that in most cases, right? So we're gonna create okay, so this is made because it's like because of how things work, right? But we want to do this anyway, I guess. Let's say we want to do this. Okay, so create dir if needed, and then it's going to be like this compiler build directory, right? And then we have this. If these are true, then I'm going to make this IR file dir, and then finally we're going to have the asm one if needed. It seems that we are not doing the oh, here's the object file, right? I was like, where's the object file one? So like this. So now let's see. Oh. Right, failed to create build directory build. We already have a build directory build, right? I think we did. So it's going to be interesting to see what happens here. So we're going to go in here, make recursive, because I think that's what's failing. So we're going to go into the recursive, we're going to make this one, right? And we're going to get like it seems so we're going to get build here. Oh wait, it's just going to make build. And what happens then? It's going to, what? Oh, it's going to look for, look for subdirectories. But then we go into, damn it. So you're going to get here, go here, right? Which is the make here. And it's going to make dir, but it's going to do that. Oh, okay. So if needed, I didn't actually, check if file exists. Oh, what? Okay. Right. Now I don't need to look at this because it should work. Should make sense. So we got it here. Let's look at my directory now. So we have the build, right? And that one is empty now because we, I guess, let me delete that one, by the way. So let's fully delete that one. So okay, that was in test. We were in resources. We were in test fragments. So here's the build one. I think this is from before, so I can delete this one. And then I guess we're going to get to LVM IR1. So LVM1, and that one is going to have these, right? You see the output here. So let's delete that one as well. And then let's run it again and see what happens. So now, there we go. We have the build directory and it's empty, right? And we have the LVM one, which is not empty. Yeah. Now, the problem is that the test program is assuming that the LL files are not in that particular directory. It's just assuming it just parse it out in the normal output. So what needs to be done then? Actually, I can run the test program here. So I think that one, maybe it's this one. No, it's not. It's just going to compile it, right? That's not what I wanted. So compile and run this test program, right here. It does. So I got all these like bunch of. Oh wait, that was not it. Use new generics, run tester program, new generics, and then we have the actual tester. So test all. This is the one I think which will run the test. Right. It's doing things here, right? So it did not compile file constants, blah blah blah, and didn't get that. So what we're going to do now, we have the test runner here. So the way it looks for the LL files, right? We're going to look at we're going to compile it, and then we're going to say like, okay, let's just put it in that normal directory. So let's see. So we're going to emit LVM, right? So here, that's what I'm saying, but where should we put that? Well, it should be in the test directory. So we can change directory to the test directory, and then all the output is going to be so we can do like command line push LVM out, and it's going to be like in the current directory, which is going to be whatever we compiled in. So something like this. And now I think the test will pause again. No, because another test is running. Yes. So let's kill that. Okay. So again, let's run that again. Here we go. So we can do the unit tests, and then here we go, and then it starts running through the tests. So now it kind of works. And by default, then it outputs things into, if you have LVM, it outputs into LVM. If it has the build, it puts in the builds. But did it put it in a subfolder? I need to check. It should have done that, but I didn't test it, so it doesn't work. So let me, okay, here we go. Here are the errors, by the way, that I wanted. So here, oh, we get to several of them. Okay, so oh no, it's just moving things around. Okay, let me pause this output, or otherwise I'll go insane from having to. Oh, it's still running. Okay, yes, go ahead then. So an in parameter may not be passed, so it's in the in out. That is a different one out like this, right? Because it's changed subtly into a different error here. So in out, in, and it has this one at line 6 and this one at line 14, right? So we can just restart this, make sure that it works, and write some release notes, changes, output into build, by default. Maybe it should remove build as well. Yes, it loves to continue and do that. Okay, maybe there's a test running. So I'm looking at my another screen here. So if I just gonna kill the process, but it likes to run, and I haven't looked at why, and because I'm lazy. Sometimes lazy is good. I think this time lazy is not good. Output into blah 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 by default. Target. But this is weird. So the object files would go in here, right? Into build. And then okay, and then output LVM ASM into LVM target and platform actually. So it works. It's so this text these tests look like they're working. I recall another problem. So another problem is when we want to delete object files and when we use C to kind of create files, does this still work, right? And fortunately, I have a small test program that I usually use for this. So it's running on CI. So this is the test project, right? And that one will use C and so on. So here's the case, and it does work, right? And it's in here, so somewhere. So here's test project, right? And let's it does have the build folder and has a lot of stuff in here. So I can just kill this and delete it and make sure that it looks good. So what happens if I run this again now? So again, it runs this from the script, right? So what we'll get here is clib, and it's empty, and there's a temp c compile here. So I would like to kind of see if I can break this in the middle. So we're running the compiler, right? And we are in the end, we invoke the linker. So I want to look at how it looks like before we actually reach the linker. So we have the linker set up. Okay, we can go from here. So linker set up. We're gonna hit this code somewhere, so linker setup will be hit. So therefore we can run the test project and see what it looks like before it does anything. So this is like if it just crashes in the middle or something. So what does it look like? And let's, we have to maybe reload from disk and kind of compare. So now see that we have stuff in here. So we have this hello, oh, from the clibs. These are the ones we have, right? And then we have our own compilation, I think, but where is that? We have, oh, wait. What? It just put it in here. What? Why? Oh, why? That doesn't make any sense. What's the project JSON here saying? So I think I need to kind of let this run, or it won't clean up after itself. But I'm going to look at very, very carefully why it doesn't do the right thing. So wait, we'll create output dir right here, and it's kind of okay. So this one is better. But when is that one called? Oh, it only does that on the output directory. Okay. Okay. Let's combine these two, I think. So we're going to, if it exists, then we have to, look at that and see that it's actually not actually a directory, or it will fail. So let's put that in here, and then remove this part, and then we have to create a directory. Have to pay that, right? And now they both do the same things, pretty much. Okay, and I need to have create output directory. This is an output directory. Okay, so what's the difference here? So we have it here, right? So we can go in before when we set this. So we get in here, right? Somewhere here. So let's see why I didn't. We go in here, I think, and set the target build. Okay, so we're going here, right? So here now the target name is the target build. Sorry, target build, and the build file is set to build, right? There's output directory too. Yeah, so the output directory this is where we want to put our binaries. And that's not the same thing. And so we're going to set all those, and then we're going to do all these funky things on them, right? And we are going to get a places for everything, I think, except for the object files. So let's see why we didn't get that. If we don't have that one, then we said it's okay. Now it's going to look better, I think. Again, we want to stop there in the linker, right? So let's see if I got stopped. Okay, so now let's see what it looks like. So we're in here, and let me reload that from disk. So now we have the object one, and we have them. Actually, these are also in the same kind of hierarchy here, and the rest of them, they are kind of just placed in here like just that we don't care about them. Okay, but when we continue after we're done here running this, it does, it does clean those up, but doesn't clean up the actual directories. So let's look at how that is done, right? Because we are hitting the linker, but that happens way like a link. So we're doing the linking thing here, and then we do the cleanup. So we do the delete object files. Now, the thing is that we don't know here which ones are from our regular list of object files and which ones are from C. So, but we do know that we are first, doing these things from C files. So these are the ones that are done already, right? So let's see here, object file next. So object files are in here. We're compiling them, and then we get more object files, right? And then let's see here. So we get another number of compiled ones, and we are getting the number of C files here, right? So unless they are compiled for the target, we can say basically at the end, we can offset the whole thing. So here's the output count, right? So when we delete things way later, right? So when we finally clean up delete the output files here, we can say, okay, but offset that by C files, right? And then, we reduce that by number of C files, something like that. Now this should work. So if I do this, this build here, then it doesn't need to recompile the C files, but we'll still invoke that, right? So I'm not sure what the problem was. I think it was a problem, it shouldn't really delete all the files, right? It has object files, right? But why does it delete it? That seems, unless, okay, it looks like it actually delete the fixed, the clean it up, all of it. But let's see here. Okay, let's delete the build file, the folder, sorry. And let's run this again. Wait, hang on, this is just for the output dynamic. Right, so this is just for the when doing a dynamic. So there we go. And then finally, what's this? Run after compile, yes. Okay. Delete object files. Now they're all, no, they don't all have that code. Okay. Now let's run this. Okay, and then we'll look in here. And let's see what happens. So we do have what? What? Okay. Okay. This wasn't what I was expecting. So, oh wait, is that the end or something? How do I add these files? Right, and sometimes they might be So there are C files, compile those C files, put them in this one, right? But what's wrong with this? So okay, yeah, the output file count, we do the output directory, and then we do that, and then we do the linking, right? And then we print things. And now what's the C file thing here? So C files, they're just C files, one C file, apparently. And let's look at the directory there. We have the object files. So the object files is object files. There we go. And like the first one should be the okay, it's the backtrace for some reason. So, and the next one is okay. That doesn't make any sense to me, but at least that explains why it doesn't work. So if we look at the first file, then that it wants to delete, we go into delete file, right? And here we are somewhere down here, and we see the first path is kind of like the environment. Then my guess is that the last one is basically the one we are. So we go through these, and at the end, I think we probably have that file from the C file in the end. So that's no, that's not it, right? So we get barfoo. Now we're getting to the C compiled ones, and then we get the clib, the C hello, the white space test. Okay, the white space test, is that something that we included or something? So they are at the end. They are at the end. That's like the important thing here. So to actually do this correctly, it's not. It's just easier than I thought. So we only need to take this output file count here and reduce that by the C file count. But how is this generated? All right. I don't remember. Does anyone remember what Soding did when the files were kind of cheap viewers and string blah 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 whatever? So does anyone remember what problem Soding had with like files like the O.O file getting deleted? Because I remember it was something like, okay, it placed a .o file somewhere. Maybe I should just like ask very quickly on the stream. So what the problem was? So does anyone remember what the problem Soding ran into when using external .o files into C3 that were compiled using C. I don't recall the details, only that they were a pain to generate in some way. Was it like they created the C file and then had to, couldn't use the C file again or something? But that doesn't make sense because. Or was it that all the .o files that were in all the I mean, you can still link that. I don't remember what the problem was. That's a problem. um, but now maybe we created problems for others here because files don't end up in the same place as they used to. Hopefully not. So we should look at where the ASM files end up, I guess. But we already know that it's going to be like a build is going to have an object, and things are ending up inside of that normally. So if someone is linking things, then it should be okay. What the heck? I thought it was. I mean, it's right now. It's just deleting files. It created itself. I think. I think. Let's see if it also kills something else. So okay, let's see the steps here. So we have we do if we have C files, right? We do the compilation. Okay, first, okay, sorry. First, we actually do the compiling files, right? So we just do with whatever we have. And yeah, should start looking at the C backend. But there are some preparations I would like to do. Okay, so anyway, we have generated the name. We're going to free the arenas. Now we have, we have a lot of memory, but it's just, we can just drop them at this point in time. Okay, then we are then going to the output files that are going to be like generated by the compiler, right? So these are the object files there, and then we have the C files and we have the C libraries, and then we compile the libraries and they produce C sources in themselves. That can calculate how many output files there are going to be. And then we start allocating some memory for that. And then we compile the C files, right? And then after that, we look at the library targets and maybe we have C files there, and then we compile those. And we're not smart about this. It's more of a let's compile some headers that might have things and such. Okay, and then we start to, go through these object files and kind of put them all first, and then finally. Oh wait. Yes, that's correct. And then because we have to compile. No, sorry, we have not compiled anything. We just reserve memory. So we do the C compilations first, but we place them after for some reason, and then we're going to do the. I'm going to print out what files that we are going to compile, and now we have this count. These. Oh wait, where are the object files from? Yes, hang on. So that's the object file count, right? So hang on, it's maybe something like that. So where's the object files from? Where are the object files here? Oh, that's the thing. Okay. So if you provide an object file that you want to go into this, that object file will also be deleted. Okay, that's very bad. Let's see here. Where do we put that? It's at the end, right? It looks like it's at the end. So then we could essentially not delete that one, which would be very sane. I don't know what I was thinking. So let's when we delete these files, I mean we have the count and we have the object. We have to do it. We should really, you know, do these in a similar way, right? But let's see here. So we're gonna delete the file, but where do we actually delete the object file? So here we go, right? So delete the object files, but we're gonna remove the object file. Files, I think that's the one. External file count. External no object file count. Okay, so we're going to remove. We're not going to have those mess things up. So let's see that it does work. I need to remove that from here, and there it is already there. Here. Oh wait, we can do it like this. So delete object files. Let's object file delete count equals output object file count minus this. Maybe like just that later happened that would change. No, this is when everything is done. So this is unsigned to. And then we use that one instead for deleting here. So now we don't have this very error prone thing. Okay, let me find all the places here. Okay, so let's run the test project. And now we should remove everything except if we have an object file somewhere, it's not going to remove that one. And it did remove everything else. And so now I need a small project where I have that could be my test program, right? So we have this small thing here. So this one is just running. Oh, that's the test runner. Let's open a terminal window, and we go into resources, and then we go into test fragments. So normally we would have something like C3. Oh, don't go that. So C make file. Okay, debug. Maybe latest. I don't know if that one is done. And then let's compile this by the way. Right, or it's going to use that debug one. Okay, wait, debug. Somewhat confusing right now because I have debug latest and debug, and they're doing exactly the same thing. Okay, but they are not the same. So okay, latest. And then we're gonna do debug stuff C3. Right? Oh, compile run maybe. Right. And now we want to make a small small C file that does something or doesn't do anything. We could have let's touch we have this folder here, so test fragments. Maybe I have some C programs already here, so nope. There should be like okay, we maybe have like touch foo C, right? So now we have a foo C somewhere. And we can now open that one, and then we have like hello C, and then include std.io, right? Okay, std.io, no end of there, and then we have puts. Yeah, we can have like that. It's okay. And if I compile this one with Clang, I should get the .o file, right? So do I get the, how do I just compile it to get an object out? I'm just gonna Google that. Yes, see. Okay, I thought it was something like that. Okay, so now we have a foo.o there. And we go into our debug stuff. There we go. And then we're going to declare, this is nice, an extern, what was the name of something like hello C, yeah, hello C function, and it's a void function, yes. So now we can do, first we do hello C, but to do so we need to link with that one. So we can do like this, and then we have foo C, foo o.o. I would say hello C. And the question is it deleted? No, it isn't deleted. It's still there, I think. We can test that by doing this again. And wait, did it work? Yes, it did work. So, and if we didn't do this thing with changing the delete count and just have that as the output file count, like that, what would happen then? I can keep doing this anyway. Oh, I didn't. I need to recompile it. I was like, why doesn't this change anything? This is the reason why I keep running through this, this kind of the IDE. But when I don't go into the IDE, I suddenly get like, oh, it's gone. Yes, it's gone. So this works. And finally, so features. Here we go. So that was annoying. I don't know why I didn't file bug for that, because it's a bug. So okay, don't delete. Don't be bad. Don't be an ass. And delete.o files. And well, can be more serious. Don't delete.o files not produced by the compiler. That was a bad thing. Okay, so I think this should kind of work now. we're done the testing, and I'm ready to kind of add all these things into the main compiler. So we did a few things here. So um, and I think there's the thing that I didn't kind of push. If I just do like this now, kind of hit push but don't push. Oh wait, did I actually push those things yesterday? I have to look at that. So where's the latest ad here? No, that's a different thing. So yesterday we were having. No, we didn't do that. So didn't I put the IO thing in here? So aliases are not. Don't delete. Okay, correctly. Correctly handle in out when interacting with in out. So that was the fix. Did I put it somewhere else or something? Hopefully not. Yeah. So these are the ones that are fixed in here. So I'm just going to push this. So our changes, let's just look at this. We added also load. We also did add like change this the way the output is handled. And what else? Is there anything else? Let's see. Here's the in-out thing that looked at yesterday. Otherwise, it's I'm fix there and the error, and then that's it. So you don't see this because it's on a different window, and but when I played with this before, and it was really not. It would just remove the window sometimes. So okay, so tell me what stream was the really one. I don't recall, but now I found it anyway. So we're kind of okay now. This is fixing that long-standing issue that he had with. I thought I fixed that at some point, or it wasn't the problem, but clearly not. And now it's fixed, and it's gonna be like a better experience when if he takes the latest and runs with that. Yeah. So thank you for watching. This was a kind of a just a stream I wanted to do quickly this evening. Actually, I was not planning on doing this on the stream, but seeing the Soding stream just before this and seeing him having problems, and he was complaining like, "Are you not using, C3?" And I think that's a fair. I mean, it's a fair um, complaint because yes or no, I'm not really dog fooding, um, and that's a problem. But my problem is that I unfortunately have a job which I do um, in my normal time. So which is like different. Actually, I end up using different languages depending on whatever the client wants me to use, and I can't use C3. And that means that when do I actually, use my own language? Well, I've done the advent of code, but the advent of codes, that's like one file. You don't really, you get some conveniences, but not every, some conveniences you understand, yeah, oh, I need this or that. But there are so many other things as you start building bigger and bigger things. And I would love to do this more, But like, and people think, okay, but why aren't you could, write C3 in C3, right? And yes, I could do that, but the problem is it will give me like the completely wrong feedback. So I'm really afraid of actually doing that, because the way I can handle things in the C compiler would not be the way I would like to handle things in a game, or in an app, or on a backend. It would be something different, very different. So, and it would be like still kind of a very narrow subset, because in the compiler, it kind of keeps solving the same problems over and over again. So, let's say you're implementing analysis on an if statement, and then there's like, yeah, and then there's a while statement, and for each and stuff like that. They all kind of have the same problem, the same kind of pattern that you keep applying to it. And there is actually not that much. It's like when I do Advent of Code, the first time I did Advent of Code, I had a lot of things that I wanted to improve with the standard library, because that would make it more convenient when I was writing that kind of code. The second time around, there wasn't as much things. There were much fewer things I had problems with, and when I did it last year, it was like not there was where it wasn't anything, because I already kind of exhausted that problem domain in terms of what feedback it could give me. So um, it's really uh, it's really this you need to have time to kind of work in different domains to kind of uh, get a good feedback uh, on what the pain points are. And it's I mean, people are using the language, and then you kind of encounter a problem. The normal thing that people do is like, yeah, this language sucks. Why does it have that problem? And it could be so easy to solve if I do it myself. It's like, what? There's a problem here. Let's solve that. So it's definitely not that I want to not fix these problems. It's that more that I'm unaware. There are some cases where it's kind of a trade-off against something else, and you can't kill one thing, or like you can't solve one thing without breaking something else. There are cases like that, but those are fairly few. So I'd really love to uh, I really like to look at people when they're using the language and kind of see what kind of problems they run into, what they don't understand, and then try to improve that. And Sadly, watching a video or listening to something, that also takes time, right? And then I have to make time for that. And just, life happens. So right now, kind of the work I'm doing, before this, I would do some consultant work, and it would make me enough money to have like maybe doing 3/4 of a full time. So I would have plenty of time doing other things. Like it would be like between half and 3/4 of a full time job. And now what I have is like a full time. So that means that I don't have as much time to do other things. Uh, and that means that if I'm doing something in C3, then that would have to be time I don't spend on working on C3 itself. But it's kind of time to do that. So what I was going to kind of look at tonight before I solve this problem was kind of look and hunt for those problems and maybe do, think of something in C3 to kind of do. And I think the way that that Jonathan Blow approached things with GIs was excellent. I mean, he had a problem that he wanted to solve, a problem domain, which is games, right? And then he wrote a game and a game engine together with the language. That's perfect. But that makes it so the language is I'm just laughing at the point I'm going to make. So if you have a compiler, you're writing a compiler in a language and do writes an application at the same time in that language, then you are going to optimize for that kind of application. So we have a lot of languages out there that are optimizing to write compilers in, because they are, their first thing that they want to do is basically write something that's good for self-hosting. But as I said, like that's self-hosting. That's a very specific task, and it doesn't give you any idea of what people will need. It's very bad. It's like if you look at something like a library for making games, you can look at whatever you want, like Raylib or something, and they are what you kind of struck by is that they basically have functions that address things that you want to do like without any fuss. So let's open a window. So there's, opening a window. Here's like putting a sprite on the screen. Whereas if you have, if you go to other libraries that seem to be like having a more of a top-down approach, you don't get like, oh, here's how you can put something on the screen, and this is like how you play music, or this. It's more of like, here's where you start your music engine with hooks, and you don't get that. Here's the simple way of doing it. Another would be like, okay, let's load a file. I mean, there's something you do all the time is loading a text file from somewhere, right? You want to load a file that you had. You want to load as binary or you want to load as text, but you want to load the entire file. But then a lot of libraries, they kind of look at, C. But they are like, okay, now you open a file and then you create a buffer and then you start reading into that buffer and you append to it, and then you close your file when you're done, and then you take the buffer and convert it. If you looked at what the Java file library looked like, that was exactly it. You would like create a file, and then you create a file stream, and then you take that file stream and start reading into your other, maybe byte buffer, and then you do that and for a while, and then you kind of take the result and close everything and take the result and convert that into an array. And that's something you could use. There was so that was like 5-6 steps. Completely unnecessary. Not only like most of those steps were only like, oh, I have to optimize or I have to partially read something or something. I mean, there are cases where you just want to read the first 100 bytes of something. Certainly, absolutely. But the use cases for most things are like, yes, yeah, load everything, load into memory, and I use something and then I throw it away. And there was like a lot of libraries, standard libraries don't have that convenience. It's like, yeah, you got to go through all these steps. And then you go to something like Raylib, and it's more like there's a one step because they already made the convenience function for you. But it's like seeing people use see without making libraries, so they keep on making the same buffer over and over and over again. You like a buffer, and then you read something into that, you just as print, and then you look at like every time you want to print something to a string, they kind of, yeah, let's run first, run as printf and get the size, and then allocate that size, print it, send it to whatever function needs, and then free it. That's like, there are so many steps into that. And all you wanted to do is have a temporary string, right? But you're not making making a function to do that. You're instead creating all these steps over and over again. And that's like, it's, there should be saying like, repeating the same code over and over again. That's the definition of insanity. It's not about dry. It's not like do not repeat yourself. It's not that kind of thing. The code might look different, but people who are not making convenience functions or convenience things that can be used over and over to simplify the code, they might think that they're doing work, but they are just making things that can have bugs. And people who are, I want this high level stuff because the low level stuff is not good, but they still keep on doing, file file output stream or input stream, put that into a buffer stream, and do all these hand rolling every time they see something. They don't have that. They don't make that read the whole file kind of convenience function. And what I want to say with that, with all that rant is you want to have a standard library, you have a language. The language and the standard library, they really, they kind of go into each other a lot. So you want to have something that does that in one step. For the simple case, because you don't have that full control, that you don't need that full control in the beginning. And even though you want the full control eventually, maybe, it's just that prototyping and everything it just makes it complicated. And also, to create such a function, you need to understand the use cases. And seeing those functions, okay, that person that wrote this part of the standard library had really knew how this standard library was going to be used, right? So when you see something like the Raylib thing, where you load something like, let's load a PNG into a texture, right? There's one thing, load this file into a texture. Understands that this is a nice thing to have when you're writing a very short game. You can just do it one step instead of having like, let's pull in, let's try to figure out what kind of file it is, and then you load it in the right thing, and then you decompress it, and then you take the decompressed thing, and then you do some extra thing, and then you load it as a texture. So that's actually how it works, how it kind of worked in a lot of cases where I can kind of load things on Mac OS. And it's worse in other cases where you don't even have PNG loaders, right? So, and the idea that you don't want these conveniences is of course insane. But if you're not using the actual PNG files and just pass this on into some other component that actually uses it, then it makes sense that you don't need to look at the thing. You just have this abstract UI image that you want to, or whatever, CG image or whatever, that you just want to pass over to some other part of the standard library because you're not using it yourself. If it's that thing, then of course it's like simple. You don't need to know it's a PNG or whatever it is because you're not actually using it. But if you're using the same thing, you want to grab something for your own use, load as a texture or something, then it's a terrible user experience to use that as a library. So it's clearly, I mean, the desktop, a desktop OS might not have a great standard library for games, I guess, but it just it's because people writing that is not expecting people to want that kind of functionality. So, long story like this is a long story, a long version of this, but I mean, you really want to use it for the use cases that you would like people to use the language for. And unfortunately, right now, I haven't had time. Um, and there are so many domains. I mean, I can say, okay, let's make this. Let's start making games, right? I can make one type of game, and then maybe make good for games. But it's also like, let's make it good for machine learning, or make it good for, web backend, or make it good for writing servers, HTTP servers. Those are quite all different domains. I mean, sometimes you want for some cases, you want some kind of dynamic loading and all of that. Yes. If you're writing an app, that's going to go on a phone. You want instead something completely different. You want it to be able to um, compile and set up all the other things around compiling it, if possible. So, like for iOS, there is like this signing, or Mac OS for that matter, the whole signing thing, and that's something that compiler could handle too. Doing compilation for two different processors and then doing the lipo thing, that's something you could put in there. So that would be convenient if your target was that like the people, your target audience would do that a lot. Never mind. Thank you for watching. If you have any questions regarding my rant, then you can ask them now. But otherwise, I guess I'll just have a look at the actions here and see that it's actually not. Oh, it's broken. It's broken. Okay, let's see why it's broken. So I actually broke it. Not the Okay, so this is interesting. Okay, so there's a hello world. So the link is complete, but what happened? So let's see. The way it works, I should have. I should really let you see this window, but let's see here. So there is a hello world, and it's like on Windows, it's linking it, but then it's not finding the file properly. So it's supposed to run a file on a project file on MSVC, but it's not. It doesn't find that. It does correctly find the other and run the ones that are just a compile, but not the ones that are compile run. So I guess we have to look into that. And you can stay with me or not. It's this is the project, right? So it's like the test project. It's doing the completely the same thing, but I might have failed to kind of place things right. So maybe there's something in Windows where I don't output in the right place. So what I find is that the output here. Let me just paste this into the. This is how it looks to me. Right, here we go. So the error message I will get is this. Okay, that was very hard to read. Let's not make that so. Okay, you have to bear with me. So we have this output, right? We have the linking, um, and we are making the layouts. This looks okay, right? So fine. Uh, and then it will build it here, right? So build object file. And these kind of look, I know this works because it said linking was complete and it was just going to launch this afterwards. But the question is, where does it put these files? So the out is here, right? So hello world win32. Um, I never thought about it, but where did we end up? What was this project that we ran here? This test project. Where did it put its binary in the end? So let's see here. So it did a run, right? So hello from script and linked, and it launched a dot hello world, which would be in the current directory run, right? So, and this test thing here is going into whatever it's inside of the test. So let's see here. That seems like a weird place. It should have gone into the test project directory. So let's see here. So it should have ended up here. Yeah, it does seem like it did. Let's see what the CI is doing and where it places things. So if you look at MSVC here, it is running running some examples flawlessly, but and then we kind of do this, and then we want to first run this, the hello world. It doesn't output anything, so and this is interesting. Dear, where is this? Oh, this is showing. This is like the emit. Oh, this is like doing. It's not running. It's running it, but it's also showing what's in here, right? So in this directory. But we just changed that, right? We placed this so that directory is now. What was that? So it was the. Let me see here. We put it in. Like here's the object, right? So it was like a LVM, and then on this one, which would be Windows x64. So this is actually the directory, and so it failed, I think, because it was not. Oh, this is interesting, by the way. Like, what does it do when I do emit LVM? Okay, so I do like this, right? So here we go. We edit the configuration to also. Why do I keep getting this? Stop having. I put this to pinned, and now it's always messing with me. Unpin, right? Stop messing with me. Here's the test project. Okay, great. Okay, so I'm not. I have to do emit LVM, right? And then if we run this now, we're gonna get this LVM in here, right, with a lot of files. But let's see what happens when I clean this. So again, I have to go into this test directory. So it should be not test fragments, it's going to be test project. And then I'm going to run a clean here. And now the question is what happens. So the clean is now deleting all of those files, right? Let's just, yeah, so these are deleted now. Okay, so that looks right. So if we have this, it might do the right thing and it might be happy about that. Let me just check that nothing else is doing the same thing. So maybe it was just this. So update MSVC path. That's my in the CI. I think that was it. That's why I wasn't happy about my push there. Okay, so I guess that was the bug, maybe. So yeah, and so hopefully we'll just have this fixed now. Okay, thank you all for watching. So have a good Friday evening, the rest of the evening here, and I'll try to get better at not sorry, try to feel try to cure this cold that I have. And unfortunately, I mean the situation with compiler feedback, I'll have to just keep on watching people using C3. That's the best cure, really. But sometimes it's hard to get time. But everything, like if something adds friction to whatever you're doing, it shouldn't be there. It preferably shouldn't be there. If there is something there, then we'll definitely look at improving that. But it's not as simple as saying like I want X, right? It's like what you're trying to do, what you're trying to achieve. So I understand the situation. All right, thank you.